Hello everyone. Traditionally, while developing machine learning or deep learning based models, the part of logging the model into MLflow was completely different. We used to serialize our checkpoints and save these checkpoints in the MLflow environment for better reproducibility. But today, as we are developing more of generative AI based applications, especially with API based models, we need a defined way to log different versions of the generative AI models. For that, MLflow provides an interesting feature, which is logging model from code. In today's video, we are going to look into an example to see how we can log generative AI models from code. Let's get started. In the previous video, we discussed how we can optimize the prompts using MLflow GenAI library, for which we used the AG news classification dataset, and the objective was to classify the news articles into one among the four categories. We are going to use the same dataset for today's experiment, but we are going to perform one another important step on top of it, which is logging model as code. Before we start with this particular experiment, let's make sure we have the MLflow server up and running. I have already started the server, and the server is running in localhost 5000. And the next important step is to copy the keys. So make sure you have copied your keys inside .env file, and I have already done it. So let's go ahead and initialize the environment. The next step is to initialize your model. As we want to log the model from code, we are going to write the implementation of this particular model in a separate Python file, for which I'm going to use the write file extension, which will copy this cell's output inside lcmodel.py. Logging model from code is fairly straightforward task. All you have to do is to create a custom class. In my case, I'm creating a class named LangChain model, as I'm going to use the chat Google generative AI, and you make sure that you inherit this class from PythonModel class. The PythonModel class is from MLflow PyFunc library, and it has two important methods to be implemented. One is the load context method. This particular method will be invoked only once in your workflow. Whenever you create the object for this LangChain model class, this load context will be invoked. And hence it makes sense for us to initialize our model inside load context. And that's what I have done. I've initialized the LM object using chat Google generative AI. And we're going to use the model Gemini tutor for flashlight, and you can specify what are the hyperparameters that you want. So once this particular object is initialized, we are going to write the predict method. The predict method has different signatures. We are using the signature with model input, and this model input is going to vary every time when you invoke with your data points. So for instance, for this particular use case, we are going to use the AG news classification dataset, and for every single invoke of your predict method, the model input is going to be an article text, and the objective is to classify this particular article into one among four categories. And hence, once we receive the article input, we load the prompt template, and then we substitute the prompt template with the actual article content, and then send it to the endpoint, receive the response, and then return the response back. And one last step for logging the model as code is to set the active model, for which we are going to use the set model implementation from MLflow models. And you make sure you add this line where you set your model by creating object of your class. Okay. Let's go ahead and run this. It's going to write the implementation into lcmodel.py. Let's open that. And here is our implementation. We have the necessary imports. We have the custom class, which is inherited from Python model. We have the load context, and we have the predict method, right? So there are a couple of best practices which we can follow. One is make sure you have all the relevant imports defined in this particular file, so that whenever you load your model and perform prediction, you don't end up with errors. And another important security point is to not expose any of the keys. While initializing the model, sometimes we provide the tokens. Do not expose these tokens directly, as because we are going to log this entire Python script as such to MLflow. Okay. So let's go ahead and log this model. For that, we are going to use the MLflow.starter. We are going to start a new run, right? And then we are going to use MLflow.python.log model. And here I have defined the model name as LC model. And this is going to be our model file, the lcmodel.py. Okay. Once the model is initialized, let's go to the MLflow UI and check out this model. The model has been initialized. Let's go to the MLflow UI. And let's refresh it. And here we have this log model examples. And here we have our LangChain model, the model which we just logged in. And once we go to the artifacts, you can see that this particular model has the entire model implementation here. So here you have the lcmodel.py, our implementation as such, logged into MLflow. And along with this, we have the requirement file, the conda file, all the information about our environment, right? So whenever you're logging your model, this MLflow.python.log model has a lot of arguments which you can specify, whether you want to add the requirement.text or you want to specify your conda environment. All these things can be done as the argument using MLflow.python.log model. So check out the implementation for more details. And let's go ahead with the next step. Now that we have the log model, we have the model URI, right? And this is the step where we are going to load our data set. So I'm using the AGVS data set. And for this particular demo, I'm just picking only 20 samples out of it. So let's wait for the data set to be loaded. It's loaded, and we have prepared 20 different samples in the MLflow's expected format, which is the input format, where you pass in the article, and the output format, the expectations, the ground truth, which is in expected response. Now that we have prepared the data, let's go ahead and load the model. So in this case, I'm just loading the model again because I'm in the same environment. But whenever you perform different experiments as such, all you have to do is to use the model URI and invoke this MLflow.python.load model and pass in the model URI to load your model. So once the model is loaded, you're going to perform the prediction. So if you just want to perform only the prediction process, you just need model.predict and send in the article as such. But in this case, I'm going to use MLflow's GenAI evaluate library, and hence the evaluate library needs the data, the scorer, the prediction function. In order to get a prediction function, I'm writing a small wrapper. Okay, the model is loaded. So let's initialize our predict function, and this is the exact match scorer, which is going to compare our expectations against the output. And if the expectation match with the output, then it's going to return true, otherwise it's going to return false, right? And here we are going to invoke the same MLflow GenAI evaluate library as we did in the first experiment, but we are going to pass in one more extra argument, which is the model ID, right? Let's invoke this and then let's talk a bit more about it. Okay, so the MLflow GenAI evaluate takes in the data, which is the training data. Here we have the 20 samples, and we have the scorer, which is the exact match scorer, which compares these outputs against the expectation and creates a score for this. And the prediction function is the wrapper, which we created for our model predict function. And then this model ID is going to bind your model ID against the evaluation. Okay, let's just wait for the evaluation to complete. Once the evaluation is successful, let's go ahead and take a look into the UI about the results of this particular experiment. While the evaluation is running, let's have a quick check on the log model. So when we log this particular model, we provide only two arguments. One is the name of the model, and next one is the path to our script, right? But when we check MLflow Python log model, this method has wide range of arguments, right? For instance, you want to log additional, say, pip requirements, or if you want to log conda related information, or imagine you're testing this model with multiple prompts and you want to specify on the prompt URIs, right? And if you want to add signature, example, there are so many different arguments available in log model. So make sure you have a look into this particular arguments and see which argument would make more sense to log along with your model and make use of it. Okay, so let's go ahead to the next part. Let's go ahead and check if the operation is done. Yeah, it is done. Let's go to the MLflow UI. And here you can see we have two runs. First one is the long chain model. This is the model logging part, and this is the evaluation, right? So here we had 20 different samples. If you go to the traces pane, we can see that we have 20 samples, and this is the ground truth, and it has been evaluated against the response, and the output is 85% matching, right? And here you have the model metrics as such, right? So which is 85%. One advantage of logging or tying this model ID along with the evaluate is that now that when we move to, say, let's move to the training runs. So this was the run where we logged our model, right? So this is the LC model which we logged in, right? So let's click on this model, and here we can see we can directly identify the evaluation of this particular model, right? Because we have tied in our model ID in the evaluation phase, and hence we are able to, when we go to the model, we can see, our evaluation of this particular model as such. So if you're, say, performing different set of evaluations for one particular model, then we just by going to the model section, you can clearly see the evaluation for those models as such, right? Now that we have logged this particular model as code, we can even check this model's script as such from MLflow UI, right? And this particular way of logging the model is quite convenient because it's not tied to one particular flavor. Imagine you want to, do this for an OpenAI based model. All you have to do is to change the part of implementation in the load context and the predict, and it can very well work for any of the model as such. So I hope this particular video was useful, and see you soon in the next video. Thank you very much.